Hey, this is Steven from RC Engineering, and we are back with my development series. We are back talking about the aerial photography drone. So we're finally going to jump into CAD and do some CADing of this drone. Again, we're going to pop up some references here from the DJI Mavic Air, and we're going to go ahead and jump to the images and take a look at some of these images to get some inspiration on how it folds, and sort of getting inspiration from there, and also looking up some sizes of some certain components and being able to take those components, see how big they are, and how I would need to incorporate them into the frame. So first we're going to start a new folder here. Arial. I don't even know how to spell it. I'm just going to call it photography drone. Oop. So we're going with a pretty close to the same size. We might make it a little bigger depending on the size of the battery that I use and stuff like that. So let's go ahead and bring this in here, and we're going to look at some things here. So we saw a view of this guy being folded. So here it is being folded, and you see that it basically goes motor to motor. Oh, this one's upside down. Does this swivel? Oh, it swivels out, right? Yeah, I think it swivels out. So here, prop goes here. Okay, that's a good idea. Prop goes up, prop goes up, prop goes down, prop goes down in order to clear the props. Because this does not fold. And then our option is just to have the props fold where they're just pinned here. And they have pinning props, foldable props and stuff. So I'm not too worried about that. I can even make some, I guess. You just take a prop, cut it off. Take those kind of props where they're kind of shaped like that. I mean, but generally they don't make them that long. That's the problem with those props. But they have those two holes, so you can just cut it in the middle and have those two holes there, and then they will rotate. But that's fine. I'll have to look at how big those holes are, though. I'm sure you've seen what I'm talking about. Anyways, and here an option for the prop guards. I don't know if I'm going to do that. So here it is opened up, and we see it's not a very big spread. It's mainly just very long. There it is. You see the little legs. And then one more time looking at how it folds in. And here's top-down view. Super nice. Pretty small though. Ooh, there's a Mavic Air versus Mavic Pro. So Mavic Pro has also got the kind of in the back, kind of like the size of the Mavic Pro, but obviously this is super portable. So the other problem we're going to have is how these are going to be either geared or something. I might even run a brushed option. It might be way easier to attach these, so it's kind of similar size. We'll see what's going on, because brushed is way cheaper to run, and also really efficient because of gearing. So maybe my first version will be brushed, and so that way I could have it do all this kind of stuff like that. But the problem is it's going to be brushed with OSD, so I mean, and also I probably want to run it 2S because I could up the voltage and then make sure that I keep the amperage low. And generally 2S is pretty much the most that you want to do on these kinds of guys. But I have some small little quad frame geared motor things from Hobby King that I could put on one of these, and it would probably be pretty nice. Already be geared and ready for the slow, and I can determine the prop speed. Which, oh, speaking of which, because I did a Trello for this guy, I was wondering, I put all the information somewhere, but I couldn't remember what it was. And here it is. So 9-inch props, 2310. 9-inch props can be hard to spin. 3S. 17.3 to 1 gearbox. 40,000 RPM is maximum efficiency. Okay, so let's just look at some things. We'll get into doing some catting, and also maybe look at some brushed motors that are already geared. That's going to give us that high efficiency. All right, so another thing that we're going to look up is DJI Mavic Air specs. So let's go ahead and do that. So 430 gram, blah, 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 blah. Diagonal distance, 213. So, so I'm thinking 230. What's a Mavic Pro specs? Let's look at the size of the Mavic Pro. So this guy folded 198 millimeters. So it's 30 millimeters longer by 83 by 83. So, okay, so it's way shorter. But I'm thinking that the Mavic Pro might be, I think it's because of the legs. Or actually it might just be taller. Oops. Yeah, I think it's just taller. It doesn't need to be as tall as the Mavic Pro. The Mavic Pro is too deep there. It is going to be that way because of the gimbal, but yeah. Anyways, all right. So let's look at this. Let's just see folded. Let's just see what we're looking at here. This is in millimeters. So let's go ahead and look at sort of like a rectangle here. This is 168. Oh, this one's going to be 83 by 168. Oh, not inches though. 168 millimeters by 83 millimeters. Alright, so there's the guy here. So that's folded. And then unfolded is 168 by 184 by 64. So that must be the legs. We're just gonna look at the frame. We're not gonna look at a 3D yet. We're just gonna look at a 2D projection. So this is now maximum 168. So how is it 168 still? I don't think it's just not as tall. 84. Okay. So there it is. Even though I don't know how that's possible, I guess it just comes straight out. And so now from here to here, it should theoretically be, when I change this to millimeters, this guy should. It says 213. Anyways, that's basically what it looks like. It says it's 213, but here it's saying 250. Anyways, so that guy versus the Mavic, let's go ahead and superimpose the Mavic on it. Or what I'm going to do is I'm just going to, no, that's good. I'm just going to superimpose the Mavic onto it. This is Mavic Pro. This is folded, is where's unfolded? Let's see where it says anything about folded. I mean unfolded. But it says here it's 335 millimeters. So up this way, let's just say it's 335 millimeters divided by 2. And then let's do this. Rectangle, center point rectangle. Let's go from here up. So that's basically what this guy looks like. Let's go ahead and turn that. So it's quite a bit bigger. I mean, not much. It's going to be way easier to carry the heavy GoPro compared to this guy, and we could run bigger props because this guy could only run from here to there. This guy could run 100 millimeter props. That's 100 millimeters, only 4 inches. While this guy, does it say what size props it runs? No. Okay, so this guy will run probably 75 or so. Here it says folded. Folded is 83 by 83 by 198, so it's basically just longer. Oh yeah, 83 by. So yeah, it's 83 by 83. So it's the same width as this other one here, so you could basically run 82 times 2, that's 164 millimeters, 2 inches. That's 6-inch props, but I want to run 9-inch. So maybe even bigger than that. I don't know if I want to go much bigger than that. So it's already a 240 drone, which is pretty big. Might even go slightly bigger. I mean, even that's a 240. That's even past 240. That's a 335. And what's a DJI Phantom 4 specs? DJI Phantom 4 specs. It's not here. DJI Phantom 1 specs. Okay. So this one, they got rid of the size and the weight options here. So let's do DJI Phantom 2 specs. Diagonal length 350. Diagonal length is 350. Okay, so I mean it's basically going to be the size of a DJI Phantom. So 350 millimeters motor. So let's go ahead and start with that. And I want it to be 45 just to give me the good stabilization. and they're just gonna pivot. So fine. Okay, so this is gonna be. Oop. This is going to be 350 divided by 2. And this is going to be 90 plus 45. And then I'm just going to do a circle. I could just do a square. That's fine. Oop. So now theoretically, this should be 350. Right. Alright, so that's my total square. And so how big do they have to be with the arms, blah, blah, blah. So the arms are going to be dedicated on the size of props that I want to run. So obviously I want to run, this has got to be 4.5 inches, and that will show the start of where my body has to be, which is pretty freaking small. But it could be long. Actually, no, it can't. So that's short of where my body would have to be. Okay, so I do now like their idea of having it towards the front of the body. I like that now. Because then I don't have to worry about it cutting into the body as much. But it's still gonna be just as close. I don't think I'm going to be able to run 9-inch. It's just going to be too big to carry. Already the Phantom's massive when it's opened up. I think I'm just going to shoot for Mavic Pro and see what the maximum size I could do for the arms and stuff. Okay, so what I'm going to do here, I'm going to change all this stuff. I'm going to change from here to here. And then this I'm going to make 335. So this to this should be 335. Okay, cool. Alright, so that's the maximum there. And then what I'm going to do is I'm going to look at what is this rectangle, center rectangle point. And this one, $198. How big is 198? By 83. Let's just take a look at that. So then this would go from here out to there. This would go from here out to there. And so what's this length here? $79. I think it could be bigger. Okay, so what's 79? It's basically 80. So that's 160 millimeters, 2 inches. That's a 6.3 inch prop. So that's a 6-inch prop. So it's just a regular flight quadcopter. So I'm gonna have to redo my numbers here, but I don't think I really want it any bigger than a Mavic Air, even though the other one's just 30 millimeters long, wider. But to get 9-inch with no over the top of this guy, it's going to be very difficult. Even if I get the efficiency I'm looking for, I'm going to lose quite a bit of thrust over top of that frame. Unless the frame is really stubby, but if it's really stubby, it's not going to fold right. So the 30 millimeters is a difference of an inch. It's an inch shorter. So 1 inch from motor to motor. But it's not 30 millimeters, 15 millimeters, right? That's like half an inch, 0.6 inches. So that'll give an extra, that'll make it 6.5 inch props. I mean, we could do that. I could live with that. What? Did it just make this box taller? Oh. Okay. Now let's take a look at it. Be a similar size to the Mavic, bigger platform there. And this guy will be 85 millimeters. Oh, there's my cat. So it's 90. So 85. I'm gonna say 86. So that's 172 millimeters, 2 inches. Is 6 3/4. So I mean, we could go an extra 25 and have that much going over top of the frame. That's fine. So we're gonna run 7-inch props, way under what I wanted to run, which were 9-inch props. Still wondering if I could get something like the Phantom, but just have it fold, not be square, but discus kind of shaped, like a circle. That's an interesting idea. Something I never thought about is, what if it had circular arms? So what if it's just a big circle? It's just like a Phantom, so I can run huge arms, and then it has, instead of this weird square base, it has a circular base. Because pretty much everything is going to be centered around the circular base. It just has to be big enough to put the battery in there. And the GPS is circular. Quadcopter GPS. So it'll be kind of like a discus, sort of. Let's kind of explore that. Because what I'm thinking is that the arms are actually curved instead of straight. Again, the curve, what it's going to do is it's going to give kind of non-linear, like, thrust angles on it. When you punch on it, it's going to want to rip those arms off. But it's going to be way easier to attach the gimbal on it than on a Phantom and stuff. Than on a different type of style of drone. So let's take a look at that. So we're talking. Let's look at this. Let's look at this other Phantom. Let me go grab my Phantom. Alright, so here we have my Phantom, of course, massive. The weighted, obviously no curved arms, but it has the problem that I'm messing with is that it needs a lot of needs a lot of room for that center section in a rectangular frame because you're shoving a big old battery in there. But mine, I could lay my lithium ions however I want. It could be a weird shaped battery. It doesn't have to be perfect. So let me see. So let's compare this guy to the specs here using my crappy digital calipers. We're talking folded of the Mavic. Let's look at compare it to the Pro. The folded is 198 millimeters. So the frame of the Phantom is 101 by 107 by 107. So that's why it's causing a lot of problems. It's so long. Why does it need to be so long? Well, the problem why it needs to be so long is it has a gimbal out in front, which would sort of throw it off balance. Because you kind of want everything to be centered around this center of mass when it's flying around, at least. So you want everything around the center of mass. It'd be way easier to put a full-size gimbal on there. So we do have a few options. I do like this because you could have the giant props on it. This guy's running, so you could have the more efficient. So this guy's running 8-inch props on it. And we have very little overlap. We could go maybe even to 9-inch and still have very little overlap. But the main reason why is it has really fat arms on it because they're injection molded. They don't have any support structure in there. So what if it says 100? So let's say it was a 100 millimeter diameter circle. Just like that. How much room could we get if it was this way, 350 millimeters divided by 2? I don't need to do the millimeters part. What is this distance from here? There. So that's 250 millimeters. That's 9.84 inches. Obviously, I don't really want to go over 9. And actually, it would be nice to even run almost 8. So let's say that this is... So now I could actually have it be smaller. Convert inches to millimeters. So we're going to do 9-inch. It's 228. So 228.6 divided by 2. Oh, wait. Wait. 114, so this could be dropped by 11. 175 minus 114. So that's a 164 millimeter arm. Actually, well, technically it's a 114 millimeter arm. So but here's the question. So, if we have, where's my calculator? There you are. Alright, where's my notebook? So we're going to do a little bit more looking at this guy, and then I have to go do some other stuff while this guy's uploading. I have to work on some machines in the garage. I'm wondering how big would this guy have to be in order to have these guys roll up to this point. Then another one roll up to this point, another one roll up to this point, and this one roll up to that point. So that's a fourth of travel. So how big of diameter would this need to be? But then again, I'm limited by the 9-inch. So let's just say 1/4 inch quarter turn, and then we have 2 pi r equals the distance. But in this case, it's a fourth of that, so this is pi over 2r is equal to a certain distance, and that distance has to be the nonlinear distance. Wow. So then you have what's the actual length of the arm, which is the distance away, because it's curved. So then you would have trig involved. So you have a curve. And that curve is dedicated by this relationship here. And then the... Okay, so I mean, but the height is basically the radius. Yeah, the height is basically the radius here. That's the height. Okay. So I guess then you're looking for a 9-inch radius then. Oh, so it has to be 9-inch radius. Okay. Right. Because if you bring this guy out, so let's say there's a circle. This guy's out like that. This I think it's 9 inches. 9-inch radius. But a 9-inch radius. Okay, so then this would have to be a 114? 114 millimeters, I think. So a 9-inch radius. Oh, 9-inch radius. So it's an 18-inch diameter. Oh man. Wait. See, I'm kind of struggling to visualize this guy, and I'll share that with you once I figure this out. So if it goes from here to there, the kick out distance is this radius. Yeah, that's the how big it is. Oh, but we want a 9-inch prop, so it has to be a 4.5-inch radius. Oh crap, so that's 224. Okay, so I get it now. So it's going to have to be a 2.4, and that's going to cause a lot of tweaking on that motor. It's going to want to twist that thing apart. So that's going to have to be aluminum or something. Or carbon fiber or something. 4.5 inches, millimeters. I mean, let's look at that, I guess. This thing's going to be gigantic. 4.5-inch radius. So that's like 200. I'm not even going to be able to get that here. Because this is already 106, and I don't know if I really want to go any bigger than that. Okay. What if instead of curved it just goes straight? That's only 70 millimeters. It's possible to go curved and then straight? So that'd be interesting if it was curved arm, and then when you deploy it, it straightens. Because then that would be The guesstimated distance is 9 inches here. So the hypotenuse is 9 inches. Well, obviously it's not going to be because it's arced. And then this is going to be 45 degrees because they're the same. So, the square root 2 over 2, isn't it? I think. I mean, I can do it on the calculator still. So what would the radius of that be? So that is just sine or cosine of 45 is equal to x over 9. Multiply 9 sine 45. 9 sine 45. That's a 6.36 radius. 6.363 radius. Okay. 6-inch radius. So that's a 12-inch total. That's massive. That's even bigger than this one. Oh, but it's not 9. It's 4.5. Oops. .5 sine 45 is equal to 3.18. So that times that, that's a 6-inch radius, which is 150 millimeters. So that's additional 50 millimeters more than the quad, which is additional 2 inches. It is quite a bit meatier. That's a big discus. But, I mean, it's quite a bit smaller discus. It's about the size of your hand. You could palm it, I believe. Yeah, I mean, you could palm it in your hand. Okay, so that's another option. So it's 6.362. That's, yeah, 100, actually it's 161.6 millimeters. So yeah, you could probably palm it in your hand. Yeah, I think I'm gonna have to abandon the 9-inch props and maybe drop it to 8-inch props. So let's see what I got here. That's 2.8 radius, so that's 5.657. I don't know if I want to go much smaller than what's already on the Phantom. Because this is 120, sorry, 200 millimeter. That's about an 8-inch prop. Alright, well, I'm going to have to think about it, because that's pretty big. I might just stay with what's on the Phantom right now, or maybe even make it a little bit smaller. I think even 6 inches I'll probably still be able to get away with it, because with a 6-inch prop, if it was straight, then that would mean 3 inches. There's 2.1 inch, which is 4 inches. No, that's what I'm talking about, 4.24. That's 107. So this would be a 6-inch prop. And so if it's a 6-inch prop, so it'd be 6 inches plus 4 inches plus another 6. Nope. So fully extended, it would be 3 inches. 3 times 2 plus 4. So the whole thing across would be 10 inches. That's actually not bad. That's obviously way smaller than the Phantom itself, wide open, because it's using 8-inch props. Alright, well, this has been a good experience here. Definitely throwing some ideas around. I do kind of like this circular idea, because it'll make for a pretty unique looking drone, and also will keep most of the stuff out of the way. I mean, you can still run a very large prop without having anything over it, really. Besides the arm, because in both situations you're gonna have the prop going over the arm anyways. So these are just some ideas. I will continue thinking about them in the coming days, and we'll take this back up maybe next week, depending if we don't work on the VR006 project in the meantime. Alright, so it's been Steven from RC Engineering, and I hope you guys like this video. Please subscribe for more videos like it. If you like what I do, please check out the link in my description for my Patreon, and you could support me through there. This summer I plan on working on more exclusive content to the Patreon, so I will let you guys know when that happens. Stay tuned. Thanks for watching. Take it easy. Peace.